All right, guys, we're starting. So the first thing we're looking at is problems 1 through 5. 1 through 5. 1 through 5 is our transformations. We want to describe the transformations that have been applied to the function. So when we look at this here, ax minus h squared plus k. A tells us one of two things: vertical stretch or shrink, and reflection is across the x-axis. So if A is negative, there's a reflection across the x-axis. If there is a number there, that tells us if there's a stretch or shrink. Now, since we look at A is negative 0.7. The negative tells us that there is a reflection across the x-axis. The negative specifically tells us that there's a reflection across the x-axis. The 0.7 tells us that there is a vertical stretch or shrink. Now, we can determine stretch or shrink based off the value of A. Now, we're not talking about the sign, we're talking about the 0.7. If that value is greater than 1, it's a stretch. If it's between 0 and 1, it's a shrink. Now, since 0.7 is between 0 and 1, it tells us that here we have a vertical shrink of 0.7. H tells us the movement left or right. Now, the value of H is 4, but would it be positive or negative? Negative 4, so that tells us that we're moving left 4. H is going to be our left or right, so H is negative 4. Guys, focus up here. Okay. 4, since it's negative 4, it moves left 4. The minus 1, our value of K tells us how far we move up or down. Now, since it's minus 1, then minus would tell us we're moving down 1. And that's all we'd have to list for this here. If A was positive, there would be no reflection across the x-axis. If A is positive 1, there's no reflection across the x-axis. There is no vertical stretch or shrink. Questions on number 5? So that one there really hit all 4 of our main ones. There's not going to be a reflection across the y-axis, and there's not going to be a horizontal stretch or shrink. We won't have either one of those. You can do it later. Questions on number 5? Let's look at 6 through 10. Well, 6 and 7 are the same type. This here, it's asking for the vertex and the axis of symmetry. Now, the general form for this here is y equals a times x minus h squared plus k. Now, it's asking for the vertex and the axis of symmetry. Now, in the general form, vertex is the point h comma k. Axis of symmetry for this here, x is equal to h. So for this here, once we find the values of a, h, and k, we can plug them in and simplify where needed. Now for number 6, the value of a is going to be 2, and it's positive. H is also 2, and it would be positive. And K is 5, and it would be positive. H, so x minus h, x minus 2. Since it's still minus, there's not a sign change from the general form to the equation we're given. H is going to be positive 2. Plus 5, so K is 5. Vertex is what? H comma K. H is 2, K is 5. So the vertex is the point 2 comma 5. Axis of symmetry, x equals h. So here x equals 2. That's it. We would do the exact same thing for number 7. 8 and 9 are in standard form. Standard form is our ax squared plus bx plus c. For this one here, it's going to be helpful to know which are values for a, b, and c, and we're going to plug them in. Now for number 8, a is what? -1, 9. B is 2/5, and C is -3. Vertex, axis of symmetry. In the general form, the vertex is the point -b over 2a, comma f of -b over 2a. And the equation for axis of symmetry is x is equal to -b over 2a. So the first thing we really need to find for this here is the value of -b over 2a. Now b in our case is what? 2/5. A is -1/9. So all we did was we took the equation -b over 2a. We plugged b into b spot, a into a spot. Now at this point here, I just grab the calculator and say negative 2/8 2/5 over 2 parentheses -1/9. So we're going to plug it in exactly like we have it. -b over 2a, -2/5 over 2 times -1/9. And it'll tell us it is 9/5. So that's our value of -b over 2a. So that does tell us the x value of the vertex is 9/5. It tells us the axis of symmetry because x equals -b over 2a, so x equals 9/5. Now the only thing we have left to do is to find the f of -b over 2a. And all that's telling us is to take the 9/5 and plug it back in for x. So we're replacing every x in the equation with 9/5, which will tell us that we have -1/9 times 9/5 squared plus 2/5 times 9/5 minus 3. So all we've done is we took the value of that -b over 2a and stuck it back in the function. Now at this point here, I would not do this by hand. I would just stick this in the calculator as we have it written and let it do it for you. So we have -1/9, parentheses, 9/5, close parentheses squared, plus 2/5, parentheses, 9/5 minus 3. So all I did was just took the 9/5, replaced every x with it, let the calculator simplify. So the vertex at -b over 2a, -b over 2a was 9/5. Plugged it in 2 spots. Took the 9/5, replaced it in x squared and x. So we had -1/9 times 9/5 squared plus 2/5 times 9/5 minus 3. Let the calculator simplify it. And we have our vertex and axis of symmetry. Questions on these two here? We're ready to look at 11 through 15. We'll look at problem number 11. Now 11 through 15 and 20 through 24, 20 through 23, these equations here are asking us to find the vertex, focus, directrix, and axis of symmetry are essentially the exact same thing. If we look at this here, they tell us that the equation is y equals -1/12 x squared. In the general form, y equals a times x minus h squared plus k. To find the vertex, focus, directrix, and axis of symmetry, we need the values of h, k, and p. But to find p, we need to know a. Now looking at this equation here, the number that is taking a's spot is -1/12. What's the value of k? Is there anything added on to the end where k is? So k is 0. H is also 0. Because there's not a number inside the parentheses x minus that number, it has to be 0. So h and k here are both 0. What is the only thing we're missing? P, and P is equal to 1 over 4 A. And again, that's just a part of the general form. A is equal to 1 over 4P. P is equal to 1 over 4A. And once we have this set up, I would just go say 1 over 4 times negative 1/12. So again, at this point here, I would just look at the general form. So vertex is the point H, comma, K. H is 0, K is 0. So the vertex for this here would be the point 0, 0. Focus is the point H, comma, K plus P. Well, H is 0. Now we still need to evaluate K plus P. So K plus P, well, K is what? 0. P is negative 3. So we're saying 0 plus negative 3 is negative 3. So the y value of the focus is negative 3. So the point for focus is 0, negative 3. Directrix is y equals k minus p. So we'd have 0 minus negative 3. We can plug that in a calculator. 0 minus negative 3, enter. Negative and negative is going to make a positive. So 0 plus 3 is 3. Replace k minus p with 3. We replace k plus 3 with the negative 3, its value. K minus 3 with 3. X is the symmetry. X equals h. Well, h is 0. That's it. Question on number 11. We're ready for number 12. Number 12 is the exact same thing. The only difference is that instead of y equals, we have x equals. But we still need to find the values of h, k, a, and p. A in this case is what? 1 over 24. That just lines up with the equation. The spot where a is 1/24. So a is 1/24. What's the value of h? 0. K is 0 because there's not a number where h and k are. They have to be 0. If there's not a number where a is at, it has to be 1. Now to find p, p is equal to 1 over 4a. So for us here, it'd be 1 over 4 times 1/24. And again, at this point, I would just take this and plug it into the calculator. 1 over 4 times 1/24 will be 6. So the value of p in this case is 6. Questions on HK, A, or P, how we found those? So vertex is H comma K, so that'd be 0 comma 0. Focus is h plus p comma k. We can fill in the k value. We still need to find h plus p. So h plus p would be 0 plus 6, and 0 plus 6 is 6. Direct 6 would be h minus p, so 0 minus 6, and 0 minus 6 is negative 6. So x equals negative 6. And last thing, y equals k, so y equals 0. For the direct 6 and axis of symmetry, we do need the equation. It has, for this here, it has to be x equals negative 6 and y equals 0. Saying the direct 6 is just negative 6 and the axis of symmetry is just 0 does not work because it is the entire equation. So we do need the x equals and y equals. Questions on 11 through 15? Because the rest of those would be the exact same. We ready to look at 16 through 18? Now this time we're going the other direction. They gave us the vertex and the direct 6. We've got to find the equation. Now the vertex, no matter which equation we're working with, is the point h comma k. Now direct 6 is nice because there's only two equations for direct 6. X equals h minus p and y equals k minus p. Since we do have y equals, it means the general form for this equation is y equals k minus p. So we still need to find the values of h, k, a, and p. The vertex tells us h and k. H is 0 and k is 0. Now the general form for the direct 6 was k minus p. And the direct 6 told us that whatever k, when we take k and subtract p from it, we should get 2. Because k minus p equals 2. Well, what's the value of k? 0. So we're saying 0 minus p is 2. Well, 0 minus p is just negative p. Now we do need to get p to be positive, so we would divide both sides by negative 1. Negative p divided by negative 1 is positive p. 2 divided by negative 1 is negative 2. Now that we've found p, we can use it to find a. A is equal to 1 over 4p. P is equal to 1 over 4a. We really need h, k, and a to find the equation, but to find a, we have to know p. 1 over 4 times negative 2. We can throw in the calculator just like that is, and it'll tell us that it's negative 1/8. Now the general form for this equation is y equals a times x minus h squared plus k. Now, again, we can get that from the general forms because the only one of the two equations that has a direct 6 of y equals is our y equals a times x minus h squared plus k. Now at this point here, we know the value of a. A is negative 1/8. The value of h is 0. The value of k is 0. And you can leave it as that there. That is the correct answer, but we can actually write it a little bit nicer. Because x minus 0 is just x. So we can simplify that to just x squared. The plus 0 on the outside plus 0 doesn't add anything. So we can really simplify this equation down to just y equals negative 1/8 x squared. That's it. Questions on this here? Let's look at 17. 17, they gave us the vertex and the focus. Now, the focus comes in one of two forms, h plus p comma k and h comma k plus p. Now, we look and see which one changed from the vertex to the focus. Well, the first value, the h value, went from 0 to 0, so that didn't change. But the k value went from 0 to -7. So this would be h comma k plus p, because we put the plus p on whichever one changed. Since k changed from vertex to focus, it gets the plus p. That also tells us that the general form for this equation, because I looked at the two forms and see which one had a vertex of h comma k plus p, the y equals equation. So that's the one we're using. Now the three values we need to find are h, k, a, and p. Really, we just need a to get the equation, but in order to find a, we have to know p. H and k are 0 and 0. Now, they told us that k plus p is -7. Well, the value of k is what? So 0 plus p is -7. Well, 0 plus p is just p. 0 plus anything is just whatever the other thing we're adding to it is. That value of p is positive, yes? So we know p. Unlike the directrix where it was negative p, we had to make that positive here. Already is. So p is -7. Last thing we need to do is find a. A is equal to 1 over 4p, 1 over 4 times -7. Now at this point here, 1 over 4 times -7, we can just stick that into the calculator. We can let it simplify it for us. Questions on how we found h, k, a, or p? Plug them in. So y equals -128 times x minus 0 squared plus 0. Questions on this here? And especially with these here, the process in which equation we have is important for plugging it in. But what we're doing is finding what? H, K, A, and P. Once we find those, we plug them into their corresponding spots, simplify where needed. And that's really it. Any other questions on those there? Now, number 19, this one here, vertex, well, vertex and directrix we already did. We're not going to have any on this that give you the focus and directrix, even on the bonus. I took them out. So for most of those there, you're given vertex, directrix, vertex, focus. Let's look at 20 through 23. Now, like I said earlier, 20 through 23 is going to be almost the exact same as 11 through 15. The only difference is that h and k are not 0. Now, it might be helpful to line it up with the general form, put them next to each other. Because even with this here, we still need to find the values of h, k, a, and p. A is what? 1/8, because 1/8 is in the place of a. H is almost +3, because x minus h, x minus 3, the sign in the middle is still negative, so h has to be positive. K is what? 2. What is the only value we're missing this time is p, and p is equal to 1 over 4 a. So we'd have 1 over 4 times 1/8. Again, at this point, just stick it in the calculator. Let it do it for you. 1 over 4 parentheses 1/8, close parentheses, enter, is 2. So it tells us the value of p is 2. We do not have to write the general forms on the test. I'm just writing them here so we have quick, easy reference between the two. Vertex is the point, H comma K. H is 3, K is 2. So the vertex is 3, 2. Focus. The general form tells us it's H comma K plus P. H is still 3. K plus P we need to calculate, so we can write K plus P. K is 2, P is 2, so we have 2 plus 2 is 4. Direct 6 in the general form is Y equals K minus P, so 2 minus 2, and 2 minus 2 is 0. Axis of symmetry, X equals H, so X equals 3. So again, this is 20 through 23 is no different than 11 through 15. The only thing that changed was that H and K had a value other than 0 and 0. The overall process, everything we did to find our vertex, focus, direct 6, and axis of symmetry did not change. But we just had values for H and K. Questions on this here? Do we need to see another example of 20 through 23? Which one? We'll look at this one here. H, K, A, and P. Well, A in our case is 4. H is -1 and K is -5. Because K is inside the parentheses this time, H is outside. So it might be helpful to write it out so that we can compare and contrast where H and K are. Now the only thing we're missing is the value of P. P is equal to 1 over 4A, so we'd have 1 over 4 times 4. And 1 over 4 times 4 is 1/16. Vertex is the point H comma K, so H is -1, K is -5, so it'd be the point -1, -5. Focus is H plus P comma K. Well, our K is still -5. We have to calculate H plus P. So H is -1, P is 1/16. So we're saying -1 plus 1/16. Is -15/16. We find that value, plug it in. H minus P would be -1 minus 1/16. -17/16. So X equals -17/16, and that's it. Questions on any of this here? Last thing, axis of symmetry, X equals K, so K is -5. Questions on these here? quickly. Number 24. Given the vertex in focus or vertex in directrix, we want to find the given equation. We want to find the equation of the parabola. Now this one here gave us the vertex. Well, in either way, we need to find the values of h, k, p, and a. Vertex in focus, vertex in directrix. We need to find the value of these four here. Now h is 7, k is 3. Now this one they gave us the focus. So again, we're trying to see what value changed. So we went from 7,3 to 14,3. Well, the 3, the value k, was 3 for the vertex, 3 for the focus. So it didn't change. But h went from 7 to 14. So we would have h plus p comma k. If the k value changed, it'd be h comma k plus p. Now that tells us how to find p. It also tells us that our equation is x equals a times y minus k squared plus h. Now the last thing we need to find is a, but to find a we have to know p. So h plus p should give us a value of 14. Now we know h is 7. So we're saying that 7 plus p is 14. We would subtract 7 from both sides, telling us p is equal to 7. Now we need to find a, and a is equal to 1 over 4 p. So we'd say 1 over 4 times 7. Again, we can, at this point here, plug that into the calculator. 1 over 4 times 7 is 1 over 28. So x is equal to, our a value is 1 over 28 times y minus k, and k is 3 squared plus 7. So we plug k into k spot, h into h's spot. If we have any negative negatives, a negative and negative would make a plus. And if we added a negative, it would be the same as a minus. Question on number 24. Let's look at number 26. Vertex still h and k. That's all the vertex is. Now, directrix, we have one of two equations, either x equals h minus p or y equals k minus p. It also tells us that this here is going to be the general form. And again, just like all of these that are a similar type, we need to find the value of h, k, a, and p. Now, h and k are given to us by the vertex. H is -6, k is -4. We don't know what p is yet. I know that k minus p should be 2. So we have that -4 minus p is 2. Now the first thing we need to do here is to add 4 to both sides, telling us that p is equal to 6. Negative p is equal to 6. But we don't want to know what negative p is equal to. We want to know what positive p is equal to. So to do that, we have to divide both sides by -1, telling us p is equal to -6. And lastly, we need to find the value of A. A is equal to 1 over 4p, 1 over 4 times negative 6, which would be negative 1/24. Last thing we have to do is plug it back in. I have those flipped. So we plug negative 1 over 24 in for A. Inside we have x minus h, which would be minus negative 6, which is just the same as plus. We would plug negative 4 in for k, but plus negative 4 is the same as minus 4, so we can just say minus 4. Questions on 24 through 28. We feel good about 24 through 28. All right. Now this one says 28 on the board, but it's actually problem number 29. So this problem here, it gives us the vertex and a point, and we have to find the parabola. So this was 2.4, the last thing we did. Now we're going to use the vertex, h comma k, and the point. Now the general form for this here is y equals a times x minus h squared plus k. Now if we plugged h and k in, we'd almost have the entire equation. Our x minus negative 6 is the same as x plus 6. Our plus negative 12 is the same as minus 12. So plugging those two values in, we have almost the entire equation. We're just missing the value of a. Now to find a, we're going to take this point 0, negative 24. We're going to plug negative 24 in for y, 0 in for x, and then simplify. Now the first thing we can simplify is 0 plus 6 is 6. Now 6 squared is going to be 36. A times 36 is 36a. Now we can't add 36a and our negative 12. We can't combine those because they are not like terms. So the next thing we can do for solving for a is to move the negative 12 to the other side by adding it to both sides. Negative 24 plus 12 is going to be negative 12. Last thing we can do to get a by itself is to divide both sides by 36. And by doing that, negative 12 over 36, we can plug that in the calculator. It will tell us it is negative 1/3. If we can write it as a fraction, it's going to be nicer to keep it as a fraction for these here. Question number 28. We have 2 problems left. Because the next one we're going to look at is a similar form, but instead of getting the vertex and a point, they're going to give the x-intercepts and a point. So we'll look at 31. Now, it tells us x-intercepts. So y equals a times x minus p times x minus q. In this case here, p and q are negative 16 and negative 2. Now they could give it to us as a point, negative 16 comma 0 and negative 2 comma 0. Those are the same thing, because when the y value is 0 is where we cross the x-axis. Bless you. Now just like the last one, we can plug in negative 16 in for p, negative 2 in for q. We're just plugging in the spots of the values that we have. Negative 16 and 2 for p and q. Now negative negative 16, negative negative 2 will give us the plus 16 and plus 2. Now the only thing we're missing is the value of A. And just like the last one, we're going to plug 72, use the point, plug 72 in for Y, negative 18 in for X. Okay. And simplify. Now the first thing we're going to simplify is what's inside the parentheses. Negative 18 plus 16 is going to be negative 2. Negative 18 plus 2 is negative 16. Negative 2 times negative 16 is 32. And 32 times A, or A times 32 is 32A. Last thing we need to do is divide both sides by 32. I'd grab a calculator and say 72 over 32 is 2. If it does give you a decimal, we can use the button above enter to convert it back to a fraction. And now that we have the value of A, we can plug it back in. Questions on given the vertex in a point or x-intercepts in a point, find the equation. Are we ready for the last problem? Last problem, given the equation, we want to find the x-intercepts, vertex, and axis of symmetry. So we're given this equation here. A in this equation is 1/4. P is 7 and Q is negative 3. One of the values, so for 7, x minus 7, x minus P, so it's just positive 7. For x plus 3, x minus Q, since it went from negative to plus, Q had to be negative. Vertex. Vertex is P plus Q over 2, comma, F of P plus Q over 2. So the first thing we need to find the value of is P plus Q over 2, which would be 7 plus negative 3 over 2. Now we can do that by hand, or we can do that in the calculator. 7 plus negative 3 over 2 is 2. So we do find the x value of the vertex. Now the bell is going to ring in a second, so we're going to finish this up first. Axis of symmetry in the general form is x is equal to P plus Q over 2. So in this case here, x is also equal to 2. Now the f of P plus Q over 2, hold on, we're finishing this here. F of P plus Q over 2, all that's saying is take the value of P plus Q over 2 and plug it back in. So we'd have 1/4 of 2 minus 7 times 2 plus 3. And at this point here, we can plug all this into the calculator, and it'll tell us that it's negative 25 fourths. 25 fourths. X-intercept is P comma 0, so 7 comma 0 and Q comma 0, so negative 3 comma 0. If you have any other questions, please ask. Also, the full video is online. Part 1 is tomorrow.